Let's take just a moment to talk a little bit about what color is, how we describe it, and how we see it. This is going to be just a little bit like 7th grade science class, so stick with me. Okay, our perception of color depends on having three things: a light source, an object, and an observer. If you only have two out of the three, you don't have color. Let's start with light. We're seeing things constantly, all day long. From the time we get up in the morning until we turn off the light at night, we're looking at stuff. Stoplights, magazines, computer screens, your kids' homework, sunsets, rainbows, whatever. But when we see things, we're not actually seeing the thing so much as we're looking at the light that bounces off them, or in the case of stoplights and computer screens, is created by them. You may remember from 7th grade science class that visible light is just a very small part of the electromagnetic spectrum, which includes gamma rays, ultraviolet, microwaves, radio waves, all that stuff. And if you take white light, the part we can see, and slow it down and bend it and separate it using a prism, you'll see that white light is actually made up of many colors, the visible spectrum. This may be really familiar for some of you. For those of you that slept through 7th grade, you're now caught up. The human eye perceives three primary colors of light: red, green, and blue. Combining varying amounts of these colors creates all the other colors we see. Dogs can only perceive two primary colors, so they see far less color than humans. Some birds perceive four primary colors, so they see far more than we do. But I digress. Let's get back to the three primary colors of light: red, green, and blue. Mix all three together, and you get white. No red, green, or blue means no light, no color, or black. Mix red and green to get yellow. Mix green and blue to get cyan. And mix red and blue to get magenta. Cyan, magenta, and yellow. These are the opposite colors, the colors used in most types of ink on paper printing. If you mix equal parts CMY together, you get black, or at least something awfully dark. Print no ink and you have white, paper or banner vinyl or whatever your media is. You get it? The two color CMY mixes go back to RGB. Cyan and magenta make blue. Magenta and yellow make red, and cyan and yellow make green. You really should know these color mixes and opposites by heart, and there's an easy way to remember them. Take RGB and CMY and write them vertically beside each other on a page. The opposite colors fall across from one another. Red is opposite cyan, green is opposite magenta, and blue is opposite yellow. To find the mixes, use a technique called eliminate the opposite. For example, to find out which two colors in CMY make green, I eliminate the opposite of green, which leaves behind cyan and yellow. Cyan and yellow make green. See? Let's try another one. Which two colors in RGB make yellow? That's right, red and green. Blue is the opposite of yellow, so eliminate it. See ya. That leaves red and green. Red and green make yellow. That's not too bad, is it? All right, now let's talk about how ink on paper works. When you have a white piece of paper, or banner material, or whatever, and light shines on it, what do you see? Your eyes see equal amounts of red, green, and blue light, which is transmitted to your brain as white. Now, let's suppose you put a layer of cyan ink on the paper. What happens? Well, you see cyan, but why do you see cyan? We know cyan subtracts its opposite color, red, which leaves behind green and blue. Your eyes see green and blue that mix together to make cyan. Good so far? Let's add a layer of magenta, and now both the red and green get subtracted, leaving behind only the blue light, so our eye sees blue. Add a layer of yellow ink to the mix, and all three colors are absorbed. We see black, or the absence of light. To save money, we use black ink for printing. That way, when we want black, we can print one color instead of 3. Since it's used so often, it's much more efficient to print just the one ink. Another tactic for saving ink is called gray component replacement, or GCR. Here's how it works. When printed in equal amounts, cyan, magenta, and yellow make a neutral gray. Darker or lighter depending on how much ink is on the page. Now, let's say there are unequal amounts of CMY ink on the page. Up to a certain point, the amounts are equal. If we can determine this gray component, we can remove that extra ink we don't need and replace it with an equal percentage of black. There are several advantages to this. Clearly, we're saving ink. But the image is also going to be more stable, less likely to color shift. The more ink there is on the page, the greater the chance for errors in color shifting. Using GCR, there's less colored ink, and the black that replaces it is always neutral.